In this problem, we are given two identical beams propped up against each other on the ground with making angle theta, and we have to find the minimum angle where the beams will not slip on the ground. We are given mu s, which is equal to 0.6. So the first step is to draw a force diagram. There is the normal force of the ground on the beam, and then there's the force of gravity. There is a force of static friction to the right because the beam wants to slide to the left, so friction opposes its motion. And then there is the force. Let's call this beam 1, and this is beam 2. So this is the force of beam 2 on beam 1. So we can write our sum of the forces equations. So sum of the forces in the x direction is 0, because we're looking at two beams in equilibrium, which is also equal to force of beam 2 minus force of static friction. So we're gonna treat this direction as negative and this direction as positive. And we also got sum of the forces y equals 0, which is equal to Fg, and so down will be negative, up will be positive, so it'll be negative Fg plus the normal force. So in this case, if we don't want it to rotate, then we're going to have to use torques. And we can choose this point, which would eliminate two forces, and we would be left with only two forces to consider. So here, let's look at this piece right here. We have a triangle, angle theta, and we have an angle here, which is 90 minus theta, right? So if this angle alpha is 90 minus theta, and this perpendicular is 90 degrees total, then 90 minus 90 minus theta, minus alpha, minus theta, that would just give you theta. So over here, right here, you would get theta, because alpha is 90 minus theta. So if this is theta, then we can write our sum of the torques equation. And sum of torques is going to have to be equal to 0. And we know that is equal to FB2 times, and let's say this beam has length L, so that would be FB2, and there would be theta here. So we're looking for the perpendicular component, so that's sine theta. So FB2 sine theta. Now Fg opposes its rotation, so counterclockwise is positive and clockwise is negative. So then it would be Fg. So we're looking for the perpendicular component, so that would be cosine theta. So that would be Fg cosine theta. Oh, and we do multiply by L here, and then we have L over 2. So it's halfway from the pivot point. And so we also do know that FB2 is equal to Fs. And we also know that Fs is just Fg times the coefficient. Well, Fn, but Fn is equal to Fg. So we know that FB2 is therefore Fg mu s. And we, okay, times sine theta L, and this is equal to Fg cosine theta L over 2. So what we're solving for is we're solving for theta. So we can divide by cosine theta, and we can cancel out Fg, so we can divide by both sides. Or we can cancel out L, and so and we can divide mu s onto this side, so we get tan theta is equal to 1 over 2 mu s. So if we evaluate this in the calculator, you get theta is equal to 39 point. It's about equal to 39.81 degrees. So what this says is that theta must be greater than or equal to roughly 40 degrees.